So we're definitely most interested in seeing what the new product developments are coming for the next year and understanding how people have made changes in the cell structures and then in their module builds so that we can understand what kind of testing or challenges we might see as those products start to come into the US market in the next couple of years. Because there have been some surprises in the US market with PERC, for example, with light-induced degradation or light and elevated temperature-induced degradation. And so it's really important for the lab to know what kind of technologies are coming into the US because that's going to drive our research agenda for reliability for the next couple of years as we get ready for those technologies to come in. I mean, we're definitely hearing a lot about heterojunction technology, and heterojunctions are actually familiar in the US because there's quite a bit of Panasonic HIT in the US market for rooftops and other kinds of applications, and that's a technology we're pretty familiar with, but we haven't seen it at such large scale from multiple manufacturers before. And so there may be things that evolve as more and more people make this technology compared to what we've seen before. Bankability is a financial economic judgment rather than a technical one. And so my group and my work at the laboratory is strictly technical on reliability and quality. And so we look at those contributors to bankability. And so when we get questions from independent engineers or test labs on how to better assess reliability, or if there's a new degradation mechanism or a surprising field observation, then we work to develop a new test to maybe see that preemptively before it could get out into the field. And so our interest in bankability is twofold. You know, our interest is in making sure that good quality product gets into the US, and so that we have high quality, high performing systems in the US. And so we're interested in what we can contribute technically to make reliability a primary driver of bankability. And there are times when it is a very important factor in bankability and other times where it doesn't seem to be counted for as much. So we want to make sure that the technical data that we can provide supports reliability and quality becoming a big part of the bankability picture. And it seems that in a lot of the module manufacturers that we see rated as high in most bankability reports are module producers that tend to take that kind of thing very seriously and have very solid quality control and reliability testing protocols. I mean, there's always a lot more hype than we see in reality. You know, the hype might be up here and reality is here, but that's still probably better than where we've been. So there is definitely going to be a benefit from bifacial. We see an enhanced bifacial yield even at small scale on our site. And that 6 to 9% that we're reporting is very significant. We believe that that's real and that's consistent with many people are seeing. You know, so we want to be able to put data out there that helps people reality check, you know, some of the hype that's behind bifacial. And if people are predicting 40% gains, that might be a little high. Maybe it's a lot high, depending, you know, if you're not in a snowfield in Alaska, for example. And so we want to help people understand how much benefit they can realize from a technology, especially something like bifacial that has clearly so much potential benefit to offer. You know, nobody should be disappointed by a 6% yield gain. That's still a huge thing. That's better than you're going to get from tweaking an interconnect or making your cell a little bit bigger. You know, it's an amazing thing to have. It's a great opportunity for sites where you have limited space and you need higher power density, or sites where you have a lot of diffuse light and you need to harvest everything you can. So it's a huge opportunity for the industry, and it's important to reality check it because there are times where it won't make sense. I mean, in the end, that's always going to be economically driven based on, you know, what kind of modules you can get and what your site looks like and what the albedo is of that individual site. That's a huge driver of whether or not bifacial makes sense. If you go to a site where albedo is generally very, very low, like just dirt, water is probably the worst case scenario, you know, there it really doesn't make sense. But even at a place like NREL, where most of our ground cover is grass and dirt, and it's often brown grass, which is not great, it still makes sense in some cases. And it really depends on whether or not you can get enough extra energy production to justify that upfront investment that's a little higher than a monofacial module. So I think it depends on developers and IEs really knowing what those individual site characteristics are in order to justify a bifacial installation. The one that surprised me the most was actually people looking at bifacial for essentially Arctic installations or areas with a whole lot of snow, because we don't think about those as good locations for solar in general because there's not very much sun. But bifacial increases the energy yield enough there that that starts to make more sense and does help wean, especially those communities that are very dependent on like diesel generation off of that. And any offsets they can get are financially beneficial, along with the sustainability benefits you would get from doing that. You know, relatively high albedo environments like deserts, you certainly see a lot in Chile. And then in certain parts of the western US, these large installations are supposed to be going in bifacial because they are, you know, calculating that that bifacial gain outweighs the initial purchase, initial investment increase. So it does seem to make sense in many different environments. Probably doesn't. I've heard people propose floating on water. That's the only one I would say don't do. You know, the albedo of water is essentially zero. That's probably not going to be a lot of gain. We certainly see a lot more interest from those countries, and it seems like a huge opportunity in order to be able to put PV in those environments where previously it didn't look terribly promising. So DOE has a study funded up in Vermont, which is a very snowy part of the United States, where they are seeing good results. It's a Sandia test site where they are seeing good results from the bifacial modules. They're also seeing faster melting of the snow off the bifacial modules, which it turns out to be a big deal because you're not producing anything while they're covered. So, I mean, I have monofacial modules on my house and they melt off really fast compared to the rest of my roof. We get a lot of snow, but apparently the bifacial is that much better, especially in a ground mount. So it does actually look pretty promising,
Great.
at least in initial data. So the lab is very active in developing the science and studying reliability that feeds into things like the IEC standards. You know, we are the voice for the data in the standards process. And that's a very important thing for us because getting accurate and effective testing into standards really does help to level the playing field across the world, where if something is 61215 certified or tested, that module should be the same around the world. And so that's a big issue. However, we've all agreed that testing is not enough. It's not predictive. And so the biggest challenge for us and the biggest technical opportunity is in developing accelerated testing methods that could lead to predictive indications of quality or reliability challenges. And that's something that is scientifically and technically very challenging. You know, if we want to make a module that would last for 50 years, maybe the hardest thing is knowing that you have it in the first place. Because there are some degradation mechanisms that we saw in the field before we had any indication to test for them. You know, as technology evolves so fast, if your technology development cycle is 6 months, but your accelerated testing cycle takes a year, you may very well get a product out there before you've had time to fully test it, and that's kind of dangerous. So we also do work on how do we make accelerated testing combined with modeling faster to help keep up with that product development cycle. I mean, we're certainly starting to see capacity spin up in the US with the Q-Cells facility, Jinko facility, Silfab spinning up in Washington, SunPower's in Oregon. So we're starting to see module fab capacity spin up in the US, which I think is a good thing. And hopefully it's durable and we see expanded spin up of that because the US market clearly wants more product. They want to put more solar in, and that's a net plus for all of us in terms of energy generation. So I think that's a good thing. Hopefully production spinning up in more places throughout the world. There's a lot in Southeast Asia that has a reputation for very high quality as well that tends to be pointed at the US market. And a lot of US companies like to manufacture here as well. So hopefully there's a good opportunity to spread production out around various places where it makes sense, especially for module fab compared to cell fab. It's just a lot easier to spin up a module fabs.